Hey everyone, thanks for your time, thanks for watching. In this video, I'll cover a few more visible activities that took place at the Kennedy Space Center in the past few days, with Artemis II hardware moving to the next processing cell. A couple of Orion milestones were completed, and the Artemis II SLS Core Stage is now vertical for the first time in the vehicle assembly building. There's more to cover with last week's press conference, and I'll go over a couple more press conference topics that are related to Artemis II. I am cutting this video a little early because of upcoming travel, so let's dig into the details. There was news on Artemis II in the past week, but let's go back to last week's update press conference on December 5th and look at more of the information and context provided there. The press conference followed hours after the decision on Orion base heat shield options was made, with NASA Administrator Bill Nelson accepting the unanimous recommendation to fly the Artemis II Orion as is with a modified re-entry trajectory to address the root cause of char loss from avcoat blocks on the Artemis I heat shield. At the same time, the space agency announced delays to Artemis II and III. Artemis II is now targeting April 2026, and the Artemis III launch date for Orion and SLS would be mid-2027. However, several launches of SpaceX Starship vehicles will need to occur in the weeks and months prior to that mid-2027 date. In the press conference, NASA provided some information about what was delaying the Artemis II target date to April 2026. Orion is being fully crew rated for Artemis II, and due to delays going back to getting Artemis I off the ground, along with the need to reuse some Orion electronics from Artemis I to Artemis II, spacecraft preparations are the critical path in the schedule. Previously, the target date was September 2025, but the breadcrumbs provided in public about the status of Artemis II preparations, which I've been reporting on all year on the channel, suggested that a launch in late 2025 was already under schedule pressure. Amit Kshatriya, NASA Deputy Associate Administrator and head of the Moon to Mars Program Office, spoke about some of the factors involved in the new delay in the press conference.
We are also experiencing a handful of issues in the performance and integration of the vehicle. We have, as I mentioned to this community back at the beginning of the year, we have had some issues with the electrical system on the vehicle, specifically when the vehicle is enduring an abort scenario. In some of those cases, in this particular case for Artemis II, the abort system on the spacecraft is active. So we need to make sure that the vehicle will have maximum capacity during those abort scenarios. We found an issue with the batteries in particular, that they were not able to tolerate the abort environment. It's pretty severe, especially when you do an abort induced by the launch abort system. So we had to fix those batteries. And we've been working on that fix for a while. We were able to completely change the way that they're mounted, that they're mechanically secured. And we have been able to complete that fix, qualify that fix. It was excellent work by the team at Eagle Pitcher in Joplin, Missouri that did that for us. It was also it was difficult for them to do it because, as was mentioned earlier, our supply chains in some of these critical areas are extremely fragile, and so we had some difficulty finding very high reliability components and in order to complete that build. But the team there was excellent, and Eagle Pitcher has a long history with us. In fact, those of you that recall, the Eagle Pitcher built the batteries that were allowed the Apollo 13 crew to be able to survive during their transit when we lost the fuel cells in that mission. The other thing we've been working on significantly is the life support system on the spacecraft. We are in the ONC at Kennedy in the Operations Checkout Center. We are conducting a full set of integrated life support system tests on the spacecraft. We are learning every day about how that system performs. We have got to make sure that every part of that is in the right configuration before we commit the crew to launch. You recall at the early part of the year, we discovered an issue with the control system of the valves in particular the carbon dioxide removal system. That anomaly has been resolved. We've also witnessed a few issues with deformation of the seat material on those valves, which has caused overboard leakage. That has also been resolved. We've also been doing performance testing of the sorbent in that system to make sure it's going to have the capacity in all the cases that we care about, including multiple failure cases. So we're continuing to characterize and learn and test that life support system, but it is taking us a longer than we thought. And so we need to get that done, and we're making excellent progress there to the point at which now we're ready, as we said, to commit to stacking.
Completing the heat shield investigation and the deliberative process contributed to some of the delay, since NASA wanted to wait until they made the decision, which turned out to be in early December. However, the work that was on hold was stacking the SLS vehicle, and the earliest that could have started was probably early November. Mobile Launcher 1 was out at Launch Pad 39B completing integrated systems verification and validation with the systems at the pad until early October, and then it takes about 3 to 4 weeks of stacking preparations inside the vehicle assembly building for Exploration Ground Systems integrated operations to be ready to begin stacking. So Orion assembly and test has been running long this year, and the date was already moving out of 2025 into 2026. In the last month or so, with stacking on hold, as noted in the press conference, at this point NASA was looking at a day-for-day slip until they made the decision. On Tuesday, December 10th, NASA Kennedy Space Center Public Affairs posted an image feature with an update on Artemis II Orion testing. The image attached to the feature shows the spacecraft being lifted out of the altitude chamber on December 5th, where vacuum testing was going on in the Neil Armstrong Operations and Checkout Building at the Kennedy Space Center. A second round of vacuum testing was needed after the initial round was performed in July. The image feature also reported that the crew module batteries that Mr. Kshatriya noted in the press conference were installed following the spacecraft's return to the Final Assembly Systems Test, or FAST cell. It isn't spelled out necessarily, but the feature also reports that the installation of the 4 solar array wings on the service module is now planned for early 2025. That at least suggests that NASA and prime contractor Lockheed Martin are ready or nearing readiness to proceed into the final sequence of installations on the Artemis II Orion before it is handed over to EGS for launch preparations. A time frame for that big milestone was not provided. There are several installations and closeouts that need to be performed before that handover can take place. And then bigger picture, once EGS takes possession of Orion, there are several months of launch preparations that need to take place before it will be ready to stack on top of SLS. Going back to the press conference, Mr. Kshatriya explained what NASA is going to do on Artemis II to mitigate the char loss on the base heat shield.
Yeah, so a couple things on the entry trajectory. As Jim said, we want to constrain the downtrack, so the period at which the vehicle hits entry interface down into where aerothermal loading stopped at 1,775 nautical miles. I wanted 1,776 nautical miles because if we're going to fly in the early part of 26, we could have celebrated the 250th anniversary at the same time. That would have been elegant, but engineering said I couldn't do that. So that 1 extra mile is important because we didn't have data. So, but the reason why we know it's safe is because so a couple things. We had to move. There are 2 things that we really want to make sure we understand at Artemis II. One is, of course, controlling the environment here, but 2, we are doing the first ever crew extraction from Orion in the open water, and our sea states need to be as good as possible. So normally, when we allow for the trajectory to occur over the Pacific, we allow for the vehicle to hit what we call a horizontal target line, which is where the vehicle intercepts the Earth's atmosphere, essentially a wide swath of ranges over the Pacific. If we were to keep the horizontal target line where it was during Artemis I, the landing zone would have been well short of what we prefer to be optimal, which is off the coast of San Diego, which climatologically has the best sea states. So what we did is 2 things. First, we moved that horizontal target line such that downtrack now would put us in the preferred landing zone. And so that helps us in terms of confidence of our ability to do that. And of course, the Navy will do everything they can to make sure that's a safe operation. But the other part of it is reducing the skip duration, and our analysis of what that skip duration will do and the gas generation that occurs during that skip dwell is sufficiently low that we're not concerned that environment for crack generation is going to overwhelm the structural stability of the char layer. And so that's based on tests. We've run those exact environments. We've run dispersions on those environments, and we've also run weather divert cases because we do have weather divert capability. The minimum the minimum guided entry capability we have is 1,300 nautical miles. Everything short of that is a ballistic entry. So we have basically 400 nautical miles of weather divert, just in case on the way back we have seas that we don't like. I mean, circumlunar free return is a little different than coming back from orbit, because we're essentially picking our landing time when we commit to translunar injection. So we have to get that right. And so we have all those parameters kind of collected together, which is where we got to that entry trajectory. And we think that's gonna mitigate all of those concerns.
So they are limiting the downrange distance from entry interface to the splashdown target area to 1,775 nautical miles for Artemis II. For reference, the Artemis I skip re-entry provided 3,176 nautical miles of range, and Mr. Kshatriya noted that anything under about 1,300 nautical miles of range is essentially a ballistic re-entry. I noted in a couple of previous videos that NASA was doing independent analysis on any constraints on re-entry trajectory that might affect launch availability, which is basically how often Orion can launch in a month and how long a launch window is on a specific day. Artemis I had launch periods that were approximately 2 weeks long every 2 weeks. In other words, there would be 2 weeks where they could launch, 2 weeks where they could not, rinse and repeat. In the press conference, I asked for some more detail on what the effect on the launch periods would be from the constraints on the Artemis II reentry, and here's how Mr. Kshatriya described that.
I think the next question was on entry trajectories, overall timeline for the entry trajectory, what that's going to look like. Can you repeat the question one more time? Because I'm sorry, I want to make sure I get it right.
No problem. It was about how the change in the reentry trajectory would change your launch availability and your launch periods and the calendar for that.
Yeah, good. So in order to constrain yourself to 1775, you basically lose the tails of every launch window. Recall during Artemis I, we had kind of repeating interval every 12 days, or every 12 days we had a 12-day window open. That's just strictly planetary geometry driven. If you at the front tails, back tails, you have to expose yourself to durations you don't want. So we're about 50% of the window is cut out, and then we have to overlay the other constraints. A lot of those constraints we're gonna push back on. The same things we did during Artemis I. We have a couple of launch azimuth and comm constraints that we can work on, but fundamentally 50%. Now that's going to make it hard to launch the vehicle. Incorporating the crew into the loading sequence also makes that we got to be really careful about that. We have a lot of data about crew time on back and how to make sure we mitigate that while we're loading these types of cryogens, and so that's something we understand. But at some level, even though it's a tighter window, a little bit more difficult to handle, I actually think it's a good challenge for the team, because as before, getting our launch probability up, getting to a point where we can do dual launch, and we can hit an HLS that's in a particular orbit and do that kind of concurrent rendezvous is going to be, it's super important to us to get that capability. So I want us to accept the challenge of, even though it's a tighter window, let's make sure we can hit it, and we're going to practice it. I think there was a question also in there about tanking test. There is a configuration depending on when the spacecraft is delivered over to the ground systems program from the Lockheed industrial zone, where we could roll kind of a shortened version of the stack to the pad. Again, we did a lot of checkouts of the mobile launcher while it was at Pad B, flowing hydrogen from the new assets that we have. So we know that up to the pad itself, we're pretty good. But there's nothing like putting the ML and the core stage and potentially even the ICPS in communication with cryogenic systems ahead of time. So if it turns out we have a little bit more time to process the vehicle and the stack is ready, I think it's the right thing to do to get the stack out to Pad B and tank up. We get a lot of operational experience that way. We'll have a lot of confidence in the sealing surfaces, and then we can roll back, accept Orion, and go back out again. The other thing we did between Artemis I and II is, you recall, we had a lot of discussion about FTS batteries and the clocks that are started there. As one of the learnings from Artemis I, we've developed a contingency pad access capability where we can recycle and reset those flight termination systems clocks while at the pad, don't have to roll back. And then also we can do, for example, engine section work and a handful of other things. So our endurance at the pad will be better as well to increase that launch capability.
I'm not sure how soon NASA is willing to post launch availability calendars for Artemis II, but it's one of those things we'll be looking for next year, assuming that the incoming administration allows Artemis II to proceed as planned. We're still not done with the press conference, though. As usual, it raises a new set of questions to go along with the ones that weren't addressed, and I'm hoping there will be an opportunity to ask some of them soon. As a result of the decision to fly the Orion base heat shield as is on a modified trajectory during Artemis II, NASA also formally gave Exploration Ground Systems the approval to continue stacking the SLS solid rocket boosters. The next pair of motor segments will start the stacking clock, and measurements of the loaded propellant and other preparations are being made before the left and right-hand aft center segments are moved to the vehicle assembly building to be mated on top of the aft assemblies. This past week, though, VAB crane operators were supporting the breakover and lift of SLS Core Stage 2 into VAB High Bay 2. The stage has been lying on its overland transportation carrier in the VAB transfer aisle since it was delivered there on July 24th. Standard work to install elements of the flight termination system and some thermal protection system work was completed since then, but the stage has mostly been waiting with the rest of the launch vehicle hardware for a few months. With still more extra time, NASA and core stage prime contractor Boeing decided to install the stage in the new vertical platforms and tooling in High Bay 2. The new tooling will be used for final assembly of the next core stage, but there is some travel work that needs to be performed on the Artemis II unit while it is vertical. It will be a couple of months or so to get the boosters stacked, and the High Bay 2 tooling allows some of that traveled work to be completed in parallel with that booster stacking. On December 10th, the 175-ton crane was attached with a lift sling to the engine section of the stage, and the 325-ton crane that supports High Bays 1 and 2 was attached to the top. The two cranes performed a breakover, first lifting the stage off of its transportation carriers, then rotating it from horizontal to vertical. The 175-ton crane and sling was then disconnected. Then the next day, on December 11th, the 325-ton crane that remained attached to the lift spider at the top of the stage lifted it up through the High Bay 2 diaphragm and lowered it down into the new Boeing platforms. The social media post that reported that notes that the stage is secured in the platforms with quad pods and vehicle stabilization fixtures, but this is new information, so those are details that need to be chased down. In addition to the traveled work, installing the stage in the High Bay 2 tooling also serves as a fit check for the platforms before final assembly of the next unit is planned to take place there. Due to time constraints, I had to finish this video a little early this week, so there may be more imagery to go through in a subsequent video. Some additional imagery was also released during the past week of the Exploration Ground Systems launch team. The launch team participated in another terminal countdown simulation on December 6th, and we saw a few images of Launch Control Center Firing Room 1 taken during that exercise. Those were released during the week. Looking at the big picture for Artemis II, Orion is back in the fast cell, vacuum testing is complete, and the modified crew module batteries have been reinstalled. So the high-level question now is where that puts handover to Exploration Ground Systems on next year's calendar, and when Orion would be ready to stack on top of SLS. In the Vehicle Assembly Building, Core Stage 2 is inaugurating Boeing's High Bay 2 facility for future production, with installation on December 11th. If the traveled work and fit checks can be completed while the boosters are being stacked in High Bay 3, that could advance the overall SLS stacking timeline, which could provide either additional time or schedule margin for downstream testing in the VAB and at Pad 39B. The question for SLS activities is when the launch vehicle could be ready for a tanking test at the pad. The next milestones, now that the core stage lift is completed, are the lift of the booster left-hand and right-hand aft center segments. The field joint mates of those segments to the aft assemblies will start the stacking clock for each booster. In the last video, I noted some of the challenges that will be faced if SLS is terminated and NASA has to move Orion to a new launch vehicle. The last time that NASA studied taking an Orion spacecraft off of SLS was going on 6 years ago now, in March 2019. The Launch Services Program, or LSP, was asked by then NASA Administrator Jim Bridenstine to look at whether it was possible to fly the Orion spacecraft for Exploration Mission 1 in the middle of the next year at the time, 2020. Exploration Mission 1 was subsequently renamed to Artemis I, and the idea was to see whether it was feasible for one or more commercial launch vehicles at the time to send that uncrewed Orion spacecraft to the moon, and how many flight test objectives could be accomplished. After Orion was canceled in early 2010, and then uncanceled at the end of September 2010, the program was flat funded. Reaching a crew-rated configuration was divided into 3 flight tests. The first one, Exploration Flight Test 1 in late 2014, was a test of an uncrewed but functional crew module on a short 4-hour-long mission. The second mission was Artemis I, which included a working service module and incrementally added functionality to the still uncrewed crew module for a flight up to 6 weeks long. The third was what became Artemis II, which hasn't flown yet, but is now projected to fly a crew of 4 around the moon in the spring of 2026. The Orion and Commercial Launch Vehicle study looked at what it would take to fly an uncrewed spacecraft in about 15 months, which is similar to how much time there is between now and the spring of 2026 if NASA wanted to fly Artemis II by then and SLS was no longer an option. Today, that would also involve crew rating, but the study enumerated plenty of other work that would also be needed to integrate Orion with another launch vehicle. At the time, although Bridenstine mostly avoided the question of how much it would cost, he did say it might require some help from Congress, meaning NASA and Orion would need more money to expedite the work. Adding crew rating work to that equation likely means even more money to fast-track a project like this today. Back in March 2019, this was also a politically sensitive subject, as it would be today. The Orion program was not willing to discuss hypotheticals at the time, and that's also probably the case today. I'm not sure if LSP would be allowed to discuss a hypothetical study today, but back in 2019, I was able to interview a few subject matter experts about that study. If the Trump administration intends to cancel SLS, this would be a subject that everyone would want to revisit, including myself. But going back to that, in the interview I did in April 2019, I focused questions on integrating Orion with Falcon Heavy, since it was flying at the time, and even today it still has the best performance for launch vehicles that are available to fly payloads of Orion's size and mass right now. But Orion is not a plug-and-play spacecraft. It does not have a common satellite bus. And at its widest, it is 5.5 meters in diameter, which won't fit in most 5-meter class payload fairings. Orion, of course, comes with its own launch fairings. The crew module's ogive-shaped fairings are a part of the spacecraft's launch abort system. Orion at launch is heavier, with its launch abort system, than when the launch vehicle makes the burn to send it to the moon, and the launch vehicle has to push and steer that approximately 35 metric tons through max Q during the early part of launch. At the time, LSP said that would create a hammerhead configuration aerodynamically, and there would be aerodynamic buffet considerations for Falcon Heavy. That wasn't necessarily a showstopper, but it was going to be an issue, because, as was said at the time, the enemy of the study was time. They only had 15 months or so. There are other launch vehicles now, like United Launch Alliance's Vulcan Centaur and Blue Origin's New Glenn with larger diameters, but those would still be configurations that would need to go into wind tunnels with Orion to gather data on aeroacoustics and aerodynamic buffet in regions like the transonic and low supersonic environments. When SLS was doing aerodynamic wind tunnel testing in that same 2019 timeframe, that aeroacoustics and buffet data went to the vehicle loads team for analysis. They were also gathering force and moment data for launch vehicle guidance, navigation, and control, and for launch vehicle trajectory analysis. A replacement launch vehicle would need to go through the same NASA certification of GNC, trajectory, and launch loads for Orion that SLS is completing now. These are a few examples of the same kind of work that isn't a showstopper, but takes time to complete and certify to NASA crew rating standards. Another example from the LSP study was horizontal integration, which would have taken time to work through. ULA's Vulcan launch vehicle supports vertical integration, but the others today horizontally mate the spacecraft to the launcher, so working out Orion compatibility for those would be more complicated. Similar comments were made about a Franken-rocket concept that was considered at the time, which was to put Orion and the ICPS Delta IV-derived upper stage on top of Falcon Heavy. There wasn't necessarily any showstopper at the time for that either, but LSP said back then that it might take several years, maybe 5, to make something like that work, rather than 15 to 18 months. Today, ULA no longer makes ICPS stages. Although no one has shown any interest, it wouldn't be impossible to build new ones. If SLS is canceled, one could also try to use the last 2 units orphaned by that hypothetical cancellation. But the point is illustrating not only the kinds of things that need to be considered in order to fly astronauts in Orion on a new rocket, but also how much lead time could be necessary to make Orion work with a new launch vehicle in real life. So that's a slightly abbreviated update on the Artemis news of the week. I'm hoping to be able to attend an Artemis media event at Kennedy Space Center next week, and if so, that would provide an opportunity to ask some of the questions about current events and the forward outlook for Artemis II in particular, but also Artemis III and IV, at least in theory. But we'll see how that goes, and I'll report on whatever I can find out. Thanks for watching. Click on the like button if you found this video informative.